Look at the sheer extremes of the Indian subcontinent. In one landmass, you find altitudes scraping the stratosphere and arid deserts baked by the sun. This diagram displays the 6 physiographic divisions of the country's terrain: northern mountains, northern plains, peninsular plateau, Indian desert, coastal plains, and islands. Students often memorize these as isolated facts, but studying them in isolation hides the logic of why they exist where they do. To master the geography of India, we must look past the surface map and instead build the subcontinent from its geological bedrock. Every single one of those 6 surface divisions is the direct chronological result of just 3 foundational tectonic blocks: the ancient peninsular shield, the soaring Himalayas, and the flat northern plains. Once you understand the tectonic forces that formed these 3 primary blocks, the complex climate, soil, and elevation of all 6 physiographic zones become a perfectly logical sequence. This tectonic model begins with the oldest rock in the region, the Peninsular Block. This solid landmass dates back to the Precambrian period. Over millions of years, this shield cracked open to form deep rift valleys like the Narmada. During the Cretaceous period, massive volcanic outpourings coated the southern triangle in heavy basaltic lava, depositing the distinct black soil of the Deccan Plateau. Then, the entire Indian plate drifted north and slammed into the Eurasian plate. The sheer lateral compression from this collision squeezed the ancient sediments of the Tethys Sea, folding and thrusting them upward into the geologically young, parallel ranges of the Himalayas. This cross-section highlights the massive geological depression left behind. The violent buckling created a deep, empty trench trapped right between the newly formed northern mountains and the ancient southern peninsula. This trench became the mold for our 3rd foundational block, the Indo-Ganga-Brahmaputra Plain. This area is an aggradational plain. It was gradually filled in by huge volumes of alluvial silt, washed down by rivers originating in the Himalayas. A stable Precambrian shield, a high-velocity tectonic collision, and a massive alluvial sink. These distinct events laid down the bedrock template for everything that followed. Let's map the first specific physiographic division onto this bedrock, the Himalayas. This diagram slices the mountain system longitudinally into 4 distinct parallel bands. The most prominent band, the Greater Himalayas, rises abruptly like a continuous wall. Averaging over 6,100 meters, this zone houses the continent's loftiest peaks and is broken only where antecedent rivers cut directly through the rock. Further northwest in the Kashmir section, glacial activity formed thick deposits of clay embedded with moraines. These formations, known as karewas, possess a highly specific soil profile that makes them exclusively suited for cultivating saffron. Looking at this schematic of the thrust lines, you can see that the structure of the Himalayas doesn't simply fade out. At both extreme ends, the mountains execute sharp hairpin turns, known as syntaxial bends. At the western syntaxial bend near Nanga Parbat, the range snaps sharply downward. The Indus River exploits this exact pivot point to carve a sheer gorge. We see a mirrored event on the opposite end. Near Arunachal Pradesh, the mountains take another sharp bend south, right after crossing the Brahmaputra River. These extreme structural environments dictate the migration and agriculture of the people living within them. In the higher reaches, nomadic tribes like the Bhotias migrate vertically to summer grasslands, while eastern slopes support populations like the Lepcha. The Himalayas function as a multi-layered collision zone, dynamically bent and shaped by sheer compressive force. Moving south, we enter the 2nd physiographic division, the Northern Plains, which sits squarely inside that massive sediment-filled geological trench. This vertical cross-section shows how the plain descends from the Shiwalik foothills. Because the region was built by gravity dragging sediments, materials settled in strict vertical order. At the top sits the Babur. This porous belt of heavy boulders is dumped at the immediate breakup of the mountain slope, forcing descending streams underground. Just below that is the Tarai. Without a steep gradient, those underground streams forcefully re-emerge to the surface, creating a wide, densely vegetated swamp. Further down the valley, we find the older alluvial uplands known as the Bangar.
This soil is dark, rich in humus, and packed with calcium carbonate. Finally, at the lowest point of the valley floor, we have the Kadar. These active floodplains are enriched by fresh river silt every single rainy season. The sheer volume of these alluvial deposits generates significant geographical anomalies downstream. In the Brahmaputra plain, the sediment buildup forms Majuli, a massive river island. By identifying this area as an aggradational plain, the local topography explains itself. You don't guess why the Babur is rocky and the Kadar is fine silt. It is exactly how gravity sorts descending sediments. South of the plains, we return to the exposed bedrock of the Peninsular Plateau. This tableland is defined by highly stable crystalline rock and massive block mountains. Its western edge is guarded by the Western Ghats. These continuous block mountains formed when a large chunk of the plateau fractured into the Arabian Sea. The opposite boundary, the Eastern Ghats, behaves differently. They are lower in elevation and highly irregular. These mountains are deeply dissected by ancient river systems that cut through the rock to drain into the Bay of Bengal. The plateau also extends far into the northeast, creating the Meghalaya Hills. This section is severed from the main shield by the Malda fault line. If we move to the extreme northwest, we find this same ancient bedrock buried entirely under the Indian desert. This is a severe water deficit zone, receiving less than 150 millimeters of rainfall per year. With low precipitation and high evaporation, the region relies almost entirely on a single large river, the Luni. Instead of exposed rock, the surface topography is dominated by undulating longitudinal dunes and crescent-shaped formations known as barchans, sculpted by constant wind. Whether it thrusts upward to form the continuous block mountains of the Ghats or sits buried beneath shifting desert sand, the peninsular block provides the unyielding foundation for the entire lower subcontinent. This split-screen cross-section illustrates the coastal plains flanking the plateau. These strips are governed by a strict structural binary between the west and the east. The western coastal plain is a coastline of submergence. The landmass dips steeply below the waterline. Because it drops off so sharply, it provides excellent natural conditions for deep water ports, but prevents rivers from forming deltas. The eastern coastal plain operates in reverse. It is a coastline of emergence, creating a broad, leveled continental shelf. This shallow emergence acts as a natural break, forcing massive rivers to fan out and construct wide delta systems. Moving offshore to our final physiographic division, the island chains display an equally stark geological contrast. The Andaman and Nicobar Islands in the Bay of Bengal are primarily volcanic, forming the exposed peaks of submarine mountains. Conversely, the Lakshadweep Islands in the Arabian Sea are entirely biological, built from the slow accumulation of coral reefs. Even at the very edges of India, tectonic principles dictate the map. Submergence versus emergence and volcanic rock versus coral physically define the country's limits. Looking at this fully assembled 3D map, the topography reveals itself as a functioning geological machine. A highly stable Precambrian shield drifts northward and collides with the tectonic plate. The sheer force folds a massive new mountain range, leaving a deep structural trench in the middle that inevitably fills with river sediment to create a massive plain. From the sharp hairpin bends anchoring the Himalayas down to the complete lack of river deltas on the submerged Malabar coast, every microfeature on the surface is the direct physical output of these macro forces. Mastering the physical geography of India requires seeing past the static lines of a textbook map and recognizing the live, predictive tectonic system operating beneath the surface.